Hello and welcome to Stock CUEbs. I'm Jonathan. Stock CUEbs are videos where we explore the language Q, spelled C-U-E. Each Stock CUEb is a video where we take a really short look at a single feature, where we investigate just one way of using Q, the language and its tooling. Just like using real stock cubes for cooking, we'll be creating a mishmash, a potpourri of techniques and ideas that we can browse through, combine and throw into the mix when we're working with Q in a real-world, serious system. Today, we're going to look at an absolutely foundational part of Q. We're going to look at the single overarching thing, the only fundamental demand that Q makes of us. Please, says Q, tell me the truth, the whole truth, and nothing but the truth. Let's take the three parts of that phrase, one by one. Tell me the truth, says Q. Well, let's start by telling Q some really simple, easy truths. On the left, you can see me editing a Q file. On the right, I'm running CUEval every time the Q file changes, and then CUEexport --out YAML, outputting the YAML form of the Q. Okay, let's add some true facts. A exists, and it's an integer. A is 1. B exists, and it's an integer, and it's larger than A. B is 2. Let's save that and see what our eval and export look like. Okay. C exists, and it's the sum of A and B. S is a struct, or an object, or a hash, depending on your background. Initially it's empty, now it has a field, P. P is the string hello. There's another member, another field, Q. It's the string world. No punctuation, no spaces. R also exists, and it's the string interpolation of P, a comma, a space, string interpolation of Q, and an exclamation mark. Let's save that and see what our eval and export look like. Okay. Lastly, a greeting is our calculated string R from earlier, from inside S, with a space added on the end and repeated. How many times? It's repeated the number of times from our calculated field C. Let's save that and see what comes out. So far, so good. This all makes sense. The flow of the values from A, from B, P and Q, all the way through to greeting, it's pretty intuitive. But now, let's change things up just a little. Let's move our definition of C on line 9. Let's move it above the fields that it refers to. And let's move our string interpolation R above the fields that it refers to. Let's save this and see what changes in the evaluation on the right-hand side. Well, apart from a slightly different output ordering, the underlying values are still the same. Let's do that again with the greeting field this time. Let's move its definition all the way to the top, ahead of the fields that it references and the fields that they reference. Let's save this and see. Well, again, apart from a change in the output ordering, the values have remained the same. This is our first big truth-based realisation about Q. True facts are true facts, no matter what order we write them down in. Q looks at what we tell it all at the same time. Everything we tell it, everywhere, all at once, has to be true simultaneously. And because of that, Q doesn't care about the order in which we state any facts. The facts just have to agree. Every Q file is just a set of true statements. It's absolutely fine if they repeat themselves. That doesn't change their truthfulness. For example, we know that the calculated field C is 3. We can add that anywhere we like where C is in scope. So let's add it here at the bottom of the file and see what happens in the evaluation output on the right. Absolutely nothing changed, because we weren't adding new information. We were just repeating facts that Q already knew. Okay, on to the second part of the phrase, tell me the truth, the whole truth, and nothing but the truth. Let's tell Q the whole truth. Or rather, let's stop telling it the whole truth, because we're already telling Q everything it could possibly need to know about A, B, C, S and its fields and greeting. We have concrete, tangible values for all those fields. Let's take away some of that certainty and see what happens. The easiest way to make Q unsure about some of our fields is to remove the concrete value that we've given to one of the early fields, B. Let's stop telling Q specifically what value B is. Let's leave in there the fact that it's an integer and that it's larger than A, but we've just removed the value 2. Now, let's save that and see what the eval and the export on the right-hand side think about that. Well, the eval has still executed, but it's less sure about things that it has less information about. B is an int. It's greater than 1. C is just A plus B, and greeting doesn't have a concrete value any longer. That's the eval. Looking further down, we see that the export seems to have failed completely, showing us a couple of error messages. And that's because YAML, and also JSON, can't express the rich constraint and type information that Q has at its fingertips. When we export from Q, which is a smart data format, into a simpler, less smart format like YAML, like JSON, we need to have told Q everything it needs to know in order to produce an export containing only what we call concrete values. Not constraints, not type information. Q has to have enough information to know the actual tangible value of everything it's being asked to export. Or the export fails, as we can see here. The value of B is incomplete, as it says, because we've only told it that B is an integer and is larger than A. The value of C references B, so it's non-concrete, incomplete if you will. So that's why we need to tell Q the whole truth, but only if we're going to ask Q to export into a less smart data format. Q is perfectly happy for our data to live in limbo, incomplete, as the CUEval shows us in the top right. But as soon as we ask for that incomplete information to be represented in a format that can't represent it, Q is going to noisily tell us that that's just not possible. Lastly, Q asks us to tell it nothing but the truth. I'll put our concrete value for B back in. Both our eval and our export are happy again. Let's see what happens when we tell Q something that isn't true. Let's tell Q that C, which we know is 3, let's tell it that C is greater than 10. As before, it doesn't matter where we put this fact, but now we're telling Q an untrue fact. Let's save and see what happens. Instantly, both CUEval and CUExport fail with the same error. C, invalid value 3, out of bound 10. We've told Q 2 facts that disagree. C can't be 3 whilst also being greater than 10. So let's fix the problem. C is greater than 2, so let's tell Q that fact and see what happens. As expected, things are repaired and nothing has changed in the output from our previous successful evaluations because we've not added to the output. Let's try something slightly different. Let's tell Q that P within S is an integer. And I'll do that at the top. So P within S is an integer. Again, instantly, both commands start failing with the same error. We can see in brackets mismatched types int and string. This makes sense. We've told Q that P is simultaneously the string hello, and we've just added the fact that it's also an integer. This lie, this non-truth, breaks Q's model of reality, and thus it refuses to allow us to carry on while these 2 contradictory facts exist simultaneously. For the sake of everyone's sanity, I'll fix this before we leave by telling Q the true fact that P is, within S, actually a string. And there we are, back to our successful eval and export. Q asks us to tell it the truth, by which we mean facts that are all compatible simultaneously. It asks us to tell it the whole truth if we're going to represent the data model in a less smart format. And it asks us to tell it nothing but the truth, because Q will figure out if we're lying to it, and it will explode noisily if we do. Thanks for watching. I've been Jonathan, and I'll see you in the next serving of Stock CUEbs.